I want to welcome everyone to our DMICE Thursday conference that we have continued in virtual mode into the pandemic. The department actually has two presentations today. We have a PhD dissertation defense later on this afternoon. But our speaker today is an invited guest, and I suppose one plus minus of the pandemic is that we have been able to have more outside speakers. Although on the other hand, we don't get to invite them to visit our great facilities and city and so forth. Although the weather today, I think it's probably just as well. It's been dumping rain. Anyways, it gives me great pleasure to introduce Oliver Berdon't Walk, who probably some of you know is a PhD student at Columbia in their great biomedical informatics program, where he is carrying out a program of research on a topic that is of interest to many of us here at OHSU as well, in terms of measuring the impact of disparate race and ethnicity definitions on natural language processing, especially from clinical data. And Oliver is, as I said, a PhD student at Columbia. He did his bachelor's degree at Stanford in computational math and computational science. He also got a master's degree in biomedical informatics at Stanford, and then pursued studies at Columbia. He's actually a native of the Pacific Northwest, and I always get myself into trouble when I try to pronounce things, but he's a member of the Ankaluki tribe. Is that how you pronounce it?
Oh, Absolutely. It means, it technically translates to children of the large-beaked bird, but its
You,
colloquialism is called crow.
okay, your audio is a little garbled.
Interesting.
Is everyone
Okay.
else you want to try talking again?
I think
Is
it
it is it okay,
it's
or
good.
is it still garbled?
It's
Uh,
still it sounds good so far.
yeah, okay.
Okay.
Okay, yeah. So people are saying better. Anyways,
Okay.
okay. Well, thank you for that. And we I don't see him here. We were actually going to have a guest who knows Oliver, Dr. Eric Broad, who's an associate professor of family medicine, and hopefully he'll be able to join us. Who also is Native American and has developed and implemented a number of programs, including the YE Scholars Program that provides a post-baccalaureate pathway for Native American students to pursue medical school and proceed through it. Hopefully he'll be able to join us. So let me go ahead and turn the floor over to Oliver, and we will look forward to hearing his talk.
Great. Thank you for the introduction. Let me get my screen sharing going really quickly. As always, let's see. We gotta choose the right application. It should be this one. Yeah. Great. Okay. Can everyone see the PowerPoint slides?
Yes, that's fine.
Great. And is my audio okay now?
Um, it's not for me. What about other people? Yeah,
Yeah. Others have the issue.
yeah.
Interesting. Um,
Yeah, it's very garbled for me.
okay. Let me try calling back in really quickly. So I'm gonna exit and rejoin. I'll be right back.
Okay.
Cool. Well, let me get my screen sharing going again. This time I know what I have to choose, so it should go a little quicker. Great. Yeah, well, thank you for those instructions. It was really great. And yeah, as Dr. Hirsch mentioned, I grew up in Washington State, and I'm not sure if you guys are having rain out there right now, but it's always something I look forward to whenever it rains here in New York City as well. Let's see. So today I'm going to be giving a talk on race and ethnicity definition biases in clinical natural language processing. And I'll start off with kind of pulling back and talking about the motivation for my PhD in general. And then I'll introduce the specific topic for today's talk, go into the methods and the results and discussions surrounding that topic. And then I'll pull back once more and talk about where I see not only the specific work going, but also my work going in the future going forward. So, as is tradition, I'll start my talk talking about the EHR. So there is a plethora of information in the electronic health record, and this can be used to facilitate care and hospital operations. We can also use this for research purposes like readmission prediction, monitoring adverse drug events, risk stratification, which can be helpful to identify high-risk patients for early intervention. And there are two main types of data in the EHR, structured and unstructured. And so structured includes disease codes, labs, vitals, medications, while unstructured includes data sources like imaging, recordings, and importantly for my work, clinical notes. So a lot of the research that I just mentioned can actually be done using structured data, but some of this information is represented in a much more nuanced form in the clinical note. And clinical natural language processing, or clinical NLP, allows us to do a lot of amazing work by leveraging the rich and nuanced information within the clinical note. And we can do things like question answering, summarization, text-based information extraction. And actually, information extraction can be leveraged for healthcare disparities research. That is, there are differences between groups in terms of health outcomes, treatment, satisfaction, and access to healthcare. And part of being able to do this research means that we have to have good data on the groups that a patient belongs to. And many times this information can only be found within the clinical note. So the important thing is that clinical NLP allows us to leverage new sources of data and either complement previous approaches with more data, or use new methods that weren't possible without access to unstructured data. And sometimes we can get by performing clinical NLP using rule-based approaches, but this is not always the case. They work very well when you can kind of anticipate what kind of information can be seen in the note. And there's been a lot of progress using rule-based approaches within clinical notes. But one of the more recent ways of coming at this is using machine learning or deep learning models to extract information and find the patterns for us within clinical notes. And this is because the clinical note is not very regular. There's lots of jargon, complex and inconsistent grammar, misspelling, and just documentation differences between institutions, and then even between specialties within the same institution. So clinical NLP allows us to deal with these differences in many different ways so that we can leverage the clinical note for research as well as healthcare delivery. For example, I've worked with extracting information from the clinical note, and it's important, and the information I've worked on extracting is very important for caring for patients with HIV. So we focus on social and behavioral determinants of health, or SBDH, and usually these are thought of in two ways. Social determinants of health, which are the conditions in the environments where people are born, live, learn, work, play, worship, and age. And these affect a wide range of health, functioning, and health outcomes as well. And then there is also social and behavioral determinants of health, which is what I work with in my lab. And though these can include environmental factors like SDH, or social determinants of health, they also include individual level factors, such as illicit drug use, sexual activity, race and ethnicity, housing status, and many others. So this information is important because it can help us to deliver more targeted care for patients. For example, in the HIV setting, it's important to know who might have trouble with medication adherence, and this can be greatly impacted by information such as housing status and substance abuse. This information is often captured in the clinical note, which is why we rely on clinical NLP in my work to extract this kind of information. And as mentioned before, this kind of information is deeply important for understanding health disparities, because we can't see that we're failing to serve a certain population if we can't see that population in the first place, whether it be racial, ethnic, economic, or any other kind of group. So when we're doing this work, we often consult clinicians on what kinds of categories and definitions would be most helpful to provide care for patients. However, being able to define these categories and then also being able to deploy these models requires ethical considerations. So I'll be mostly talking about why we need to be careful with ethical considerations when it comes to defining categories, but I have a scoping review in the pipeline that talks about the second point as well. So first, I'll look at this from an ethical point, because that's kind of what initiated my work in this area in the first place. There are a lot of power dynamics that go into, and politics that go into who gets to define categories. So even categories like race and ethnicity have groups who get to define what racial and ethnic categories we use and who belongs to which one. For example, many tribes have complex and nuanced kinship systems to define who is and who is not a part of the tribe. However, this didn't drive so well with the settler colonial state, so many of us now use an imposed system of blood quantum. And this determines whether or not you're part of the tribe by how much Native American blood you have in you. And this actually goes back to a very interesting political beginning, since in the beginning, the US needed one, free labor and land. So blood quantum and the one drop rule have a lot of parallels going back. So as you can see, there are ethical implications in defining these categories. There are also tangible health outcomes for these health implications as well. And one paper that I found really sums this up very well is operationalizing and analyzing a two-step gender identity questions, methodological and ethical considerations. So in this paper, Kidd and the other authors found that when you group gender diverse youth in different categories, this has an impact on not only how affirming these categories can be for those patients, but also the health outcomes of the research you do. And in their case, they were looking at suicide ideation. They found that using a larger, all-encompassing categories obscured important differences between groups, and that while it can be difficult to use more affirming categories because of things like sample size, it was important to be able to use these when you can, as they uncovered more nuanced findings. And so this is where my work comes in. There is not only an ethical and moral imperative to examine the categories that we use, but also the real-world question on whether or not our definitions of patient demographics and categories impact health disparities research. So today I'll be talking about a first step in examining just how differences in how we define categories, specifically racial and ethnic categories, can enter into our data sets and models used for identifying this kind of information about patients. So as I said before, a lot of my work deals with healthcare disparities research, and healthcare disparities exist at multiple levels within our healthcare system. And race and ethnicity can help us identify, understand, and address health disparities. And this is because race and ethnicity are significant predictors for health outcomes because of racism, discrimination, and other social cultural factors within the US. And clinical notes provide a rich source of race and ethnicity information that can be extracted by clinical NLP models to guide healthcare disparities research. And as of late, there's been a lot of interest in how these models can be biased against certain groups. And so clinical NLP models that systematically mischaracterize certain racial or ethnic groups will absolutely perpetuate health disparities instead of addressing them. And so this brings me to the gap that I want to address with this work. And that is, it hasn't been studied the extent to which inconsistent definitions of race and ethnicity can bias clinical NLP models. And so I'll be exploring this with two questions. The first is, when creating text data sets, what information should annotators rely on to identify race and ethnicity information? And the second is, what kinds of biases do clinical NLP models inherit from data with disparate definitions of race and ethnicity from different annotators? So in today's talk, I'll be presenting a framework to be able to answer these kinds of questions, along with some preliminary results on question 2. And in order to answer these questions, I need to situate my work along two main research avenues. The first is deploying NLP models to extract race and ethnicity from clinical notes. And most importantly from this is work by Scholl et al., who used a rule-based method to extract race and ethnicity mentions from clinical notes. And they identified significant differences between those with only structured race and ethnicity data versus those with only unstructured race and ethnicity data. And next, there is work on identifying which features are most important when making predictions for models. This helps us to see how disparate definitions of race and ethnicity can enter into a model. And there are many approaches to doing this, whether it be using a built-in mechanism within certain models called attention, or perturbing the model to identify important features, or by using gradients. And so far, there doesn't seem to be a best approach for one size fits all best approach, but using gradients, specifically the approach by Sundararajan et al. Is a promising approach, and that's why I start using it in this work. So with the motivation and background, I want to take a moment to talk about a concrete example on how we can measure, one, what information correlates with clinicians' race and ethnicity labeling, and two, what kinds of biases do models inherit from different race and ethnicity definitions. And then I'll get into the exact specifics of what my methods are going to be. So let's say that we give these three sentences to classify race and ethnicity from clinicians. Clinician 1 and clinician 2 are in agreement on the first two. We see that they both label the sentence as Native American and the second sentence as African American. But we can see that they're in disagreement on the final sentence. And what we can see is that clinician 1 might be picking up on the fact that this person's from France, and maybe they think about people in France as only being white, while clinician 2 isn't quite willing to make that leap of judgment there. So let's say we trained a model on sentences labeled by clinician 1 and clinician 2. What would this model learn? What patterns would it find when making classifications, and how would it classify? By looking at the race and ethnicity assignments made by clinicians, we can determine what information in a sentence correlates with their assignments. And then we can answer our second question by training a model on the sentences from clinician 1 or clinician 2 or both, and examining what information it's picking up on. So essentially what I'm doing is I'm asking the same question, but I'm asking it of, one, the clinicians who are going to be helping us to create these data sets, and then I'm asking it of the model that's learning from these data sets. So I'll go ahead and formalize this intuition in the next section, as I described the methods that make up our approach to answering these two questions above. So first I'll talk about the data set, how we labeled or annotated this data set, and then how we trained a model on it, and finally, exactly how we're going to measure disparate race and ethnicity definitions in clinical NLP. So we use the MIMIC3 dataset as we wanted to be able to contribute a publicly available race and ethnicity corpus for others to do research on. And I may use the term corpus every now and then. Essentially what that is just a data set of sentences that in this case are going to be labeled. So we took all the discharge summaries that we could from the MIMIC3 dataset, as these summarized a patient's stay at the hospital best and often included initial notes about the meeting of a patient. We also use the Natural Language Toolkit, or NLTK, and some of our own heuristics to split clinical notes up into sentences. We then filtered sentences likely to contain anything and marked sentences that were, we filtered out sentences that were not likely to contain any race and ethnicity information, and we marked sentences that were likely to contain this information. And this was an approach following Scholl et al. So first, we looked for terms associated with patient demographics, like patient, PT, male, female, or the term year-old, as well as section headers and for social history and past medical history. So this allowed us to really focus on sentences that were likely to contain information about race and ethnicity, or at the very least, patient demographics. We then went and marked each of these sentences looking for race and ethnicity keywords. So this could be like AA, African American, Native American, or Indian. And though not all of these were hits because there's some ambiguity, for example, if you see a sentence that's talking about a patient and you see the term white, it may mean the patient's race, or it may be talking about the patient's white blood cell count. And so this allowed us to balance the kinds of data sets, the kinds of sentences that we're going to be annotating, because we want to find data sets that actually do have race and ethnicity information. But we also didn't want to bias our own labeling too badly, and we want to be able to explore to look for sentences that had information, but maybe we weren't picking up on with our keywords. So once we had our data set, and this is going to be a corpus of sentences, we want to be able to label these sentences with information that could potentially indicate race and ethnicity. And I refer to this in this work as race ethnicity indicators. And they're split up into two categories: direct indicators, which are explicit about the race or ethnicity of a patient, and then indirect indicators, which may or may not contain enough information to infer the patient's race or ethnicity. So some examples of these would be patient states they're Native American versus patient lives on the Crow reservation. A little bit of background. So I come from the Crow tribe, so the Crow reservation is in Montana. So the first row, we can see that both these sentences indicate that this person is Native American. This first example can be very clear about that in the first sentence, but the second example, we might be a little bit less sure, just because maybe living on the reservation, you don't necessarily have to be Native. And then in the second row, we can also be sure that this patient is white because of how the clinician worded this. However, in the second sentence, we might not want to make this call because we're not completely sure about whether or not someone from France is always going to be white or not. So in general, we can see that direct indicators are very certain, while indirect indicators can be less certain, and sometimes even to the point where you may not want to make the call at all. In certain cases, it may be that there's enough information there to make a call. In other cases, you may need more contextual information to be able to do that. So in this work, we broke the indicators down into 4 different categories, 2 indirect and 2 direct. So the first direct indicator is explicit mention of ethnicity. So patient is an elderly Hispanic male presenting with, the note can go on. The second direct indicator is an explicit mention of race. Patient is a 22-year-old African-American male. An indirect indicator is language. So patient required a Spanish interpreter. And finally, country, nation, or geographic ancestry. So patient recently immigrated from Canada would be an example of this. And as you can see, in each example, I've underlined the section of text which contains the indicator. So Hispanic, African-American, Spanish, and Canada. During this annotation phase, what we actually did was we went and not only we picked out the piece of text within a sentence that contains the information that we're looking at, and then labeled that piece of text with one of these 4 indicators. And the reason we chose these indicators was that we saw that these are the most likely to actually potentially contain information that could be used to infer a patient's race or ethnicity. There may be others, but these were by far the most common that we found when we were going through the notes. And so this work has actually already been completed, or this phase of it at least. And we ended up with 17,281 sentences that were annotated for indicators, and around 28% of those contained at least one race and ethnicity indicator. As you can see, indicators about race were the most common, followed by language, country, and then ethnicity. The next step in this process is then to take these same sentences, all 17,000 of them, and label them for race and ethnicity assignments. So this is going to be done using clinicians to go through and annotate all these sentences into 7 racial categories and 4 ethnic categories. So the ethnic and racial categories predominantly come out of the US Census. We wanted to use those because we thought, they're pretty easily understandable by anyone who's going to be going over these notes. We also included 2 extra categories in each one, not covered and no information indicated. So not covered is used when there is a race and ethnicity label that a clinician may want to assign, but it's not covered by one of our categories. And then no information indicated can be used when a sentence contains no information that can be used to infer race and ethnicity. So in this phase of annotation, we wanted clinicians to go through and annotate these notes with minimal guidance. That is, we really want to get an idea of exactly how they think about race and ethnicity using these categories, and only with the definitions given by the US Census. So then once we're able to do this, we're actually going to have clinicians, I think we're looking to have 10 clinicians do this, and we're going to have all 10 of them overlap on a subset of around 5,000 sentences, so that we can go through and actually start comparing to see how do different clinicians annotate the same sentence with regards to race and ethnicity. Once this is done, we can then take these labeled sentences and use them to train a race and ethnicity classification model. So this model will take in sentences similar to what the clinicians were doing. It'll then encode these sentences into using BERT, which encodes them into computable representations known as contextual word embeddings. So these embeddings convert a word into a vector space representation that can also take into account the context of the surrounding word. We'll then use a LSTM classifier or a long short-term memory network to read over each word and make a final classification at the very end. So the reason that we chose BERT here is because it has very good performance in a wide variety of tasks, and it's also what's known as pre-trained. That is, it doesn't start with no knowledge of text. It starts with a little bit of knowledge as it's read over multiple different genres of text and has some understanding of what different words mean and where they should occur. That's a very hand-wavy way of putting that. So if there's anyone who takes offense at me saying that a machine learning model understands something, absolutely able to walk that back. We also like using BERT because it reduces just how data hungry our model is. As you may know, deep learning models are incredibly data hungry and require a lot of data to train. That can be very difficult to do when you're labeling these sentences by yourself using people who have very limited time. So BERT here is actually not learning anything new from these sentences. It's what we call frozen. And then it's just it's just encoding those sentences. And then the LSTM classifier is actually what's learning how to make the classification. And so this brings me to how we'll be measuring the disparate definitions of race and ethnicity between clinicians and how these disparate definitions might affect models. And the secret to being able to do this lies in the indicators that we labeled in the first phase. So really quickly, because it's a work in progress and we're still annotating the notes for race and ethnicity labels, still trying to get clinicians to do that, one thing that we can do is go through and create not a synthetic data set because we're using actual clinical text, but we can use indicators that we have to go ahead and label some sentences with whether or not it's a sentence about a Black patient or about a white patient. And this is because we can use the indicators for explicit mentions of race and look for keywords to do that labeling. The model can then be trained on this preliminary data set as a kind of a proof of concept through what exactly we're going to be doing. And so what this looks like is, let's say we have 4 sentences. Each of them has an indicator label for race, country, and then race again. And then with each of these indicators, we also have the text from the original sentence that's associated with that. And so this allows us to create a very simple data set, taking this text and looking for keywords and classifying it, which allows us to kind of do a proof of concept model. So once that model is trained, we want to be able to go through and look at feature importance. That is, we want to measure just how much an output score can be attributed to a single input, where an input here is a word that goes into the model. And in this work, I'm going to be calling that feature importance. So gradients are a really good way to do this. This roughly breaks down to taking your input value and multiplying it by the gradient with respect to the output, because the gradient tells you a little bit about how much the output of the model changes with respect to a change in the input of the model. So we use the approach by Sundararajan et al., which is implemented in Python through a library called Captum. And we use this because it had 2 guarantees. That is, one was called sensitivity. So for every input A and input B that differ in only one feature, and also the model has different predictions for those 2 inputs, then that different feature should have a non-zero attribution to the output. And finally, implementation invariance. So if 2 models have the same output for all inputs, even with different implementations, the attributions should be equal between the 2 because those models are functionally equivalent as they have the same exact outputs for all the same inputs. Okay, so now we have sentences with indicator annotations, a model trained to classify race and ethnicity, and the ability to examine what features or words the model is picking up on. Now we need to be able to measure just what race and ethnicity indicators correlate with important features from the model, as well as for clinician labeling. So in order to measure the difference in race and ethnicity definitions by clinicians when assigning race and ethnicity labels to sentences, we'll compare the distribution of indicators across labeled sentences. So from this small example, we could say that clinician 2's assignments don't really correlate with country or language indicators, and they opt to rely on only direct indicators. So here I've highlighted some of the indicators in the sentence. So Native American and AA are race indicators, while France is a country indicator and Spanish is a language indicator. So the way that we can tell that there's a difference between clinician 1 and clinician 2 is, beyond just eyeballing what they've done. We can also do this by comparing the distribution of these indicators that we see across all sentences labeled by clinician 1 and by clinician 2, since they did this work independently. The next step is then to see what happens to a model once we train it on a corpus from clinician 1 or clinician 2. So we can take a similar approach to the previous step, looking at what indicators correlate with race and ethnicity predictions. But we can also do something interesting by looking at what important features the model is picking up on for each input. And here on the bottom left corner, you can see that important features are going to be sections of text that are highlighted in gray. So, and these are important features that are picked out by the integrated gradients method by Sundararajan et al. So as we can see in this example, we have some exact matches where the feature importance matches up exactly with Native American and AA. We have some matches that pick up on one of the indicators, so France, but also picks up on a different one. And finally, we have an example where the feature importance doesn't pick up on anything that is related to an indicator. So in order to be able to measure these three phenomena, we're using three different metrics. The first metric is called A1, the fraction of sentences where at least one important feature overlaps with the indicators. So as you can see, the first three sentences would score points for that, while the fourth sentence would not. Then we have EO, which is a fraction of sentences where all important features overlap with the indicators exactly. And in this case, only the first two sentences would get points for that. And finally, TOC, which is a fraction of important features that overlap with individual indicators. And so while the first two metrics were at a sentence level, this one is at a individual indicator level. So we see that the first indicator, the second indicator, and the third indicator all get points, while the fourth indicator does not. So those are the methods that we'll be deploying to answer the two questions from before. And today I'm going to present some preliminary results on the second question. That is, what race and ethnicity information correlates with a model's output? So we went ahead and already trained the model that I was talking about earlier on the kind of toy data set that we talked about. And we find that this model actually does really well, which isn't too surprising. The task is essentially a keyword task, and for all that deep learning, it does really well in the training data set and has a slight dip on the test data set, which makes sense. But because of that discrepancy, there may be a little bit of overtraining going on. And because of we use a near even split, our micro and macro F1 scores are very similar. That is, we use a 40-40-20 split between black, white, and no label for sentences. And so, when we saw this, we were very excited. The model seems to be learning well. But then we want to see, does learning to do this task well also translate over into picking up the right features? And so using the integrated gradients, we were able to see that the model does pick up on some features that make sense. If you ever, read any papers or watch a talk about someone where they present a kind of an interpretability method like this, you're going to see examples like this where it's like, wow, they're doing amazing. This is so great. And, I was very happy with this. So the darker green highlights indicate words that were very important for prediction. And we can look at that for sentences that contain information about white patients. It's picking up on some information that makes sense. So Caucasian here is picked up. While the first sentence, we start to see some things that might be going wrong. It's picking up on male, most importantly, and then elderly and white are kind of picked up on. And then we start to see some sentences that are very long and things start to go a little bit haywire. So in this sentence, you can tell that, from some of the recent metrics, the model tends to highlight a lot of terms that are important for really no discernible reason to a human. We can see that there are some words here that are in green, which don't really make sense. But we can also see that the term Caucasian, which is at the, I'm not sure if you can see my mouse or not, but which is at the right side, middle right, is still picked up. And really quickly, this is probably like no other clinical note you've ever seen because there's these weird little pound symbols going on. This is happening because of how BERT splits up words when it's learning. And finally, another example where I'm not really sure what the model is picking up on here. It's important to note that in all these examples, the model actually made the right prediction. But in this example, this is a general, well-appearing African-American woman in no apparent discomfort. The term African-American is not picked up at all by the model, but it still makes the right prediction. So this kind of gives us a feel for how the model is doing. In some cases, it's picking up very well on specific indicators and placing a lot of weight on them. In other examples, it can still pick up on some of those features, but it starts picking up on some random words that we may not really understand. And finally, there's examples where it's making the right prediction, but it's picking up on things that have nothing to do with race or ethnicity. And so this gives a little bit of intuition with what's going on, but we want to be able to formalize this. And as a quick reminder, we'll be using these metrics from the previous slide, so A1, EO, and TALK. And we'll be running that on the test data set to see what the model picks up on. So overall, the model does very well with A1 and TALK. That is when there's that the model is able to pick up on at least one of the features, or at least one of the indicators, and even at a token level, it usually picks up on even at a word level, it usually picks up on the indicators as well. But we can see that EO is very small, very close to 0 in most cases. And E0 is it has to have perfect overlap. And what we were seeing before in some of those examples where the model is picking up on some of the indicators, but also picking up on some random things too, that's what's really hurting EO right now. We also see, I also split this up into sentences with the label for Black or African American and the sentences with labels for white. And we see that actually the model does much better on Black or African American than it does for white. And I also noticed that the feature importance made sense more often when the sentences were shorter, which is also a phenomenon we kind of saw with some of these. So it doesn't really make a whole lot of sense, but when you get shorter sentences, it does. So today I discussed our approach to measuring how race and ethnicity indicators correlate with race and ethnicity labeling for clinicians and NLP models. And this relied on a two-step annotation process to collect race and ethnicity indicators and then actually labeling those sentences. I also presented some preliminary findings to suggest that the model learns to attend to some indicators very well, but there's also a lot of noise. And so, and importantly, model performance wasn't really an indicator of whether or not the model learned to pick up on information that we'd expected to pick up on. And that's kind of where the limitations start to come in. So we saw that longer sentences were something that the model struggled with. And that might be because of the decision rule we use when you're talking about important features. When we were picking out important features, we got a score for each feature from the integrated gradients, and then we use a cutoff to determine if a feature was important or if it's not. And it may be better that we use a different cutoff or that we use more of a, maybe not even using a cutoff at all. But it could also be that we're asking a model to think like us, and that's just not the case. Models don't necessarily have to think like we do, or that is, models don't have to necessarily make predictions like we do when given the same input. And evaluating these features, feature importance methods, is a known open-ended task right now. So my next steps with this work are to first improve the identification of important features using the feature importance that we have. I think it's going to take some time to get right, but I think we have a good start with the preliminary results that we have now. I also need to collect those clinician annotations to be able to perform a clinician and indicator analysis, as well as do the analysis on a model that actually learned from different clinicians. And then I'd like to repeat the experiment, maybe using a different model instead of a long short-term memory network that is known to have some issues with very long sentences, and clinical notes have very long sentences because it's just because that's how they're written. Maybe a convolutional neural network would be able to handle these longer sentences better. And then finally, I would want to look at do differences between models result in meaningfully different cohorts of patients? So that is, if I was doing research on HIV readmission prediction, and I want to see, does our model predict well for Black patients or white patients, and I was going to split patients up between Black and white using the model that we developed here, would that result in significantly different research outcomes? And then something I think would be really interesting to do is to kind of follow in the tracks of this paper, right for the right reasons, which talks about being able to constrain the important features for a model when it's making predictions. And I think we have a unique opportunity to do that here because if we want a model to think like us, we may have to constrain exactly how it's making those predictions using the indicator variables that we have. And I'm not exactly sure. I think I have a little bit more time, but let me know if I need to leave more time for questions.
Yeah, no, you're fine. You've been going about 40 to 45 minutes, so
oh, great. Okay.
Plenty of time for questions.
Awesome, awesome. All right, yeah, I'll be done pretty soon here. And so the last thing I want to do was kind of open up with the, I guess, pull back again and talk about the future directions I see for my work. And I think I can ground this in two papers which have really caught my attention recently. The first paper is from my own department, and which one of these authors is my own PI, so full disclosure there. And this paper discusses the impact of a more fine-grained ancestry mapping tool that can be better used to understand healthcare disparities beyond using really messy group categories like race and ethnicity. And so in that paper, they discussed, they found that there was a huge genetic difference within racial and ethnic groups, which makes sense. I think it was something we've heard before. And essentially what this boiled down to was an argument against using race and ethnicity data as a proxy for genetic ancestry, which makes sense when you consider that there's a lot of historical context in these categories. As I said before, categories are political and they don't happen in a vacuum. So there's a huge opportunity here towards disentangling biological and clinical indicators from social and cultural aspects of health. Because I think we will continue to use race and ethnicity going forward in clinical research. I think we may start to back away from it to different degrees. And instead of using it as a proxy for genetics, we also may move away from using it as a proxy for social and behavioral determinants as well. And I think that's where my work comes in. We'll need methods to understand not just genetic context of a patient, but also their social and behavioral determinants of health context as well. This kind of information can really allow us to drill down and understand, what it is that we mean when we say something like Native Americans have a higher risk for diabetes. Is it only because there's a genetic risk, or are there some socio-cultural and historical factors at play there too? And the second paper that's really been exciting for me is by Zosi et al. And this paper really questions whether or not the Belmont Report can really protect American Indian and Alaska Native people when it comes to research. And one of the main points here is that not all of our approach to ethics, that is tribal ethical frameworks, focus on the individual. A lot of them are more about the group and community well-being. And so the Belmont Report really focuses on individual autonomy, which may be incongruent for different tribes. And so this paper got me thinking, if we can question our fundamentals like the Belmont Report, can we question how we define and measure ethics when it comes to AI? So specifically looking at something like indigenous fairness metrics, how would that work in clinical AI? Would this include non-human centered considerations for our other kin? Would we have more to do with how a model is deployed and who in the community gets to vet that model before it is used in the community? Or maybe it would focus on how we formulate fairness measures that focus not just on the outcomes for the individual, but focus on how this might also affect the community. And finally, bring this all together, I think that it's really exciting that we're moving away from using race and ethnicity as a proxy for so many different factors. But there's still concerns with those in power, including myself, forcing these categories onto different people, which might be incongruent with their own identities. And I think that we need to be very careful and include community experts and scholars with degrees from these communities in the equation if we're going to do this right, without repeating the mistakes of the past. So I'll end there, and I want to say thank you to my lab mates, as well as my committee, Dr. Dina Demner-Fushman, and my PI, Noemi El-Haddad, as well as the training grant funding them on. And if anyone wants to look at these slides later, I have some works cited here that you're more than welcome to peruse through. But I'm happy to take questions now, and I'll stop sharing my screen if I can figure out how to do that.
Great, thanks. Very, very interesting talk. We usually give people the option of either unmuting and asking questions or typing into the chat. I don't see anything in the chat, so I will ask the first question. How much, I was trying to, as your work was going by, trying to determine whether your model may pick up on other things in the text, including biased or derogatory. There was a paper recently about language in medical records, and maybe biased words that are used oftentimes in the context of African American or Native American patients,
Right.
and so forth. Which would seem to potentially, it doesn't really bias your model, but it may end up biasing things that you use your model for, like health determinants and so forth.
Yeah. So, I mean, when we get clinicians to actually annotate these models, that's something I'm going to be looking out for. And like you said, it may not be that this biases the model prediction at all. It may perform just as well as any of the other models, but it's going to be very important for, if a clinician is using this, or if someone finds out this model is being used in their own healthcare records, they might want to know how much can they trust this model. Is it picking up on things that they deem derogatory to their own sense of identity? And so, I don't think any of the indicators that we're using would pick up on any derogatory comments, but there were some, actually, no, there were some race and ethnicity terms that really aren't used anymore. I think I saw a term for Asian that isn't just, it's not, it's very outdated and not used anymore. So it may be something that the model learns to pick up on. But yeah, I think it'd be something we'd have to look into more specifically rather than just using the indicators that we have.
Yeah, I'll let others ask the question, but I mean, it may not be derogatory language. This may be, kind of a biased term that gets used in the context of patients of a certain racial or ethnic group.
Absolutely. I mean, one thing we might see is like, it may pick up on sickle cell disease a lot when predicting if a patient is African American, which like there is biases there. There's some genetic information there as well, but we might not want our model to pick up on that. But yeah, that's a good point.
Yeah. Oh, I see that Eric made it. Welcome,
Hey,
Eric.
Oliver. Thank you
Hey.
so much for joining us here today in Portland virtually.
Yeah.
Sorry we can't have you in person. I'm kind of curious how your model has worked within the context of racial misclassifications, because what I don't understand, and maybe you went over this and I just didn't catch it, is like you're relying on other people's interpretation of someone's race and how they document it, right? And
Yeah.
so, like, even at OHSU, like, I've encountered a number of people who the chart calls African American, or other other providers will identify the person as African American, and then as soon as I met them, they're like, hey, I'm a citizen of the Seminole Nation, and it's like, everybody gives me all this stuff about African American, this and that. He's just like, yeah, but I'm a citizen of Seminole Nation, like that's how they identify, right? And so, like, how has your model worked in that context of like racial misclassification or racial identity misclassification?
Yeah. First off, I think it's a super important question because, and that's why I want to be so careful about this work, is the model is, this is different than the model just making a mistake and not getting the label that the person assigned to this sentence right. This is a much broader question of, we have clinicians who may be eyeballing a person. Maybe they ask, what's your race or ethnicity? How do you identify? And maybe they know that down, but more often than not, maybe not be something that happens. And so, I haven't looked into exactly how that would happen, because using the Mimic data set, we can compare to the race and ethnicity information they have in the structured data. We can also look at maybe this patient has multiple notes and certain clinicians identify them differently. And that could be an indicator that what you're talking about is happening. But we're also just going to miss a lot of times when clinicians just eyeball this patient and assign race and ethnicity without asking what they really identify as. And so I don't think this model would be good for handling anything like that. Something I've been approached about is using this model to, fill in people's race and ethnicity data within our own EHR, and that was something I absolutely bristled at, because it's not something we should do. Like, what we should be doing is asking, what is your race and ethnicity? How do you identify? And using that. And I think this model might be useful for going back and doing retrospective analysis. But I think it's a good point that looking at how does this model perform when we know what the race ethnicity is of this person because it's something they self-identified as, but the clinicians or the annotations that this is learning off of don't reflect that properly. And my guess is it's not going to pick that up at all.
Just a quick comment. What I thought you were going to do with your presentation is I thought what was going to happen is that you had like Native American, African American, person born in France, and like someone who's Spanish speaking. And I thought at the end you're going to be just like, yeah, and this person self-identifies as American Indian.
Right. Yeah.
Or is an American, is this a federally recognized tribe or something like that? Like that's what I thought was going to happen because like I've seen those nuances. Anyway.
Yeah.
Thanks for joining us today.
Yeah, absolutely. It's good to be here. I'm really happy about it.
Other questions, comments?
I had one question. Thank you so much for this talk. It was really interesting. But I was wondering, so you said that you froze the BERT model, right?
Mm-hmm.
I was wondering why you chose to freeze it instead of fine-tuning it in some way, and including like fine-tuning it with a classifier on top of it, as opposed to the separate training of the classifier.
Yeah, so the separate training of the classifier. Yeah, so the main reason we did that was because BERT has an immense amount of weights that it has to learn. And given that our data set is way smaller than what the Googles and the Facebooks are going to be using, we want to make sure that we didn't too terribly overtrain our model. Because given that many degrees of freedom, the unfrozen BERT would probably learn really specific details in the training data set. And if we had a larger data set, I would be more comfortable with using an unfrozen BERT and just letting it run wild because I think it would do very well. But I think my main concern was how small our data set is compared to how big data sets usually are when people use BERT for them.
Okay, yeah, that makes sense. Yeah, because in a project also using sort of like health-related data with this, we used BERT in both a fine-tuning way and in a non-fine-tuning way, and actually did find that fine-tuning was fine, but we had, I think, like 12,000 examples, so I don't remember how large your data set was, but yeah.
I mean, it's something I would definitely be open to try.
Yeah.
I think it could do well, but I think in this one we had 1,600 sentences, and I had to split those up into training and testing.
Right. Yeah, that's definitely a lot smaller. So.
Yeah.
Thank you.
Yeah, thank you.
So I had a question. I don't know if we're like raising hands or what, but I had a question. I mean, apologies if you mentioned this earlier, but have you thought about experimenting with other kinds of sentence encoders besides just using BERT?
Yeah. I mean, it's not something I've looked into as of yet, but stuff moves so quickly. I remember when like Elmo, BERT, and I think it was ULM Fit were like the big ones on the block, and now we have like I think Albert, and there's a bunch of other ones from Hugging Face, or implemented by Hugging Face. But yeah, so I think there are some that I could use to Hugging Face, and I know there's a couple other I can't quite remember the name, but they actually get around the issue of BERT being such a big model and being so data hungry. I could use one of those, and I think it's Distill BERT or something like that, and it might learn just fine if it was unfrozen too. But I think it's a good point. There are definitely others I could try.
Well, and specifically for like a sentence level classification or for like a hierarchical classification task like this, something that was trying to capture the whole sentence might be. But I think the BERT thing was also a fabulous way to go. I really enjoyed the talk. I should have said that first. Thank you so much.
No, thank you. I'm just taking notes really quickly because these are really great ideas. Thank you, everyone. Yeah.
Hi, this is Aaron. Can I ask a question? Hi. I enjoyed your talk as well. I'm just wondering, did you use the clinical BERT, or which specific version of BERT did you use? There's like a whole plethora of them now, and it'd be interesting actually to compare how sort of generic language versus supposedly clinical language would identify phrases and pick things up.
Yeah, yeah, that's a very good point. Clinical BERT does much better in the clinical setting, which absolutely makes sense. BERT was trained on a very general corpus using a lot of internet stuff. For this one, we used, I think, BERT, one of the smaller versions of BERT, just straight out of the box. We probably get a lot better performance if we use clinical BERT, as you mentioned. And again, Hugging Face, the people who implement all this has made it so easy where I can just take BERT, download it, and then put it straight into their architecture. So it makes it really easy. But yeah, a good point. I think there are lots of different BERTs to use, and clinical BERT would probably boost performance as well. One thing we were worried about, though, was if it's going to be a true testing set, if BERT's already seen the mimic clinical notes, it may not end up mattering, but it's something we consider.
Yeah, I hear what you're saying. I mean, if you're, just thinking out loud, maybe just because BERT's just trained on the language and not on a classification task, maybe it doesn't matter, that it, because it's essentially trained on a different, language encoding task. And so, if you're just using it for the classifier, whatever the outputs of BERT are into, putting it into whatever classification algorithm, that'd be another thing that I would, I guess this may be a little heretical. Stephen can comment on this, but everybody wants to use deep learning for absolutely everything. But I do think it's worth looking at some of the older algorithms with the output of the embeddings to see if they do any better or different with the classification, and their interpretation might be easier. I mean, I know this is really heretical, but if you put it into like a decision tree and you actually got the logic that it was using, that would be very, very interpretable, and not just some of these weight things where you have to kind of make a arbitrary distinction between, what's a high weight and what's not, kind of thing. But in any case, I really enjoyed what you did, and obviously there's just a million variations that could be compared.
Yeah. Oh, no, absolutely. I mean, I think there's a good spot for traditional machine learning models to do this. I mean, the interpretation is a lot clearer, so definitely worth a shot, I think. I see a question in the chat about long sentences being a greater challenge for accurate analysis. Yeah, so my intuition here, I think what this person's getting at, let's see. Yeah, what they're getting at is the longer models had really just weird, wacky interpretations because the weights were all over the place for the different features. I think what this gets at is that the LSTM starts to break down when you put in longer inputs. This is kind of a known thing with recurrent neural networks. LSTMs fix this to a degree, but not all the way. And so I think what we're seeing is just the backwards gradients going through when we're calculating our important features, getting a little bit mixed up for that, or the model is getting kind of confused when it goes through as well. But that's my intuition going on there.
Oh, whoops.
Oh, yeah,
I don't see any more questions. So thank you for presenting your work to us. It's very interesting, and actually maybe at some future time when you're out in these neck of the woods, we can actually have you visit in person and update us on your work. So again, I want to thank you for speaking at our conference, and we'll look forward to hearing more as your work progresses.
Great, thank you. It was enjoyable to be here. Yep.
Yeah, bye-bye.